I would want to extend a very warm welcome to Bas. Bas is an independent test automation consultant. He's also a test automation trainer. He's a very active attendee of various conferences. He's a developer himself at restassured.net. It's a library designed to write tests for HTTP APIs. A very warm welcome to you, Bas. We are very excited to listen to your talk about API security testing.
Thank you so much for having me, Dipti. How are you doing today?
I am good. How are you?
I am doing fine, doing fine. I just came into the office and now I've got the opportunity to talk to a lot of people, actually, as I can see. You've got a lot of participants, so well done.
Yes.
So, do you want me to jump right in?
Yes, over to you, Bas. You can take it over.
Awesome. Sounds good. Can you please quickly confirm that you can see my screen and um, what I perceive to be the world's ugliest slide deck?
No, we can see your screen and you can see your slide as well.
Awesome. So good day, everybody. I wanted to say good afternoon because it's afternoon for me, but I think this is sort of a global thing with people in all
Mhm.
kinds of different time zones. Very confusing. So let me just stick with good day. As Deepti said already, my name is Bas. I'm an independent test automation trainer, consultant from the Netherlands. I've been in testing and automation for some 20 years now, doing lots of different things, engineering, consulting, training, public speaking, a little bit of everything, really. And what I'd like to talk to you about today is, you probably guessed it, API security testing. Are you sure your APIs are secure? Why this topic? Why API security testing? Basically, because of the evidence, the numbers on this slide. These are numbers from 2022, so I couldn't find anything more recent. But even back in 2022, 83% of all the internet traffic is API driven. So 83% of all the data exchanged between systems on the internet is exchanged through APIs. And that's a lot of data. And unlike servers, file systems, hard drives, databases, APIs are pretty much out there in the open because they allow us to exchange data between systems over public protocols, HTTP, MQ, JMS, you name it. A lot of HTTP, actually. Which means that it's a relatively easy to access attack vector, a relatively easy way to get access to a system. So we need to make sure that all of the data that's being exchanged is secure. And unfortunately, not every company is as successful as they should be with this. High profile API security breaches, data breaches are reported on an almost weekly and sometimes even on a daily basis. And then, of course, there's all kinds of rules and regulations and laws that prescribe organizations on how to deal with the data, how they should be handling, how they should be securing their data. API security testing in general, that's something that we leave to the experts, to security experts, security testing experts, um, black hat, white hat, red hat, brown hat, whatever kind of color hat you're wearing, and those kinds of people. And yes, security and security testing is a highly specialized topic. It takes a lot of deep, highly specific security testing knowledge. But the good thing is, there's a lot we can do as well. So this is not a talk about super deep, super specific API security hacking kinds of techniques or patterns or whatever. This is not a talk brought to you by a security testing expert because I'm not. But there's a lot that we can do with common API testing tools and a healthy dose of curiosity, creativity, and common sense, which I think is what we as testers bring to the table anyway. Not the tools, but definitely the curiosity and the creativity and the common sense, hopefully. So what I want to do today is instead of just talking about APIs, I want to show you some API security testing experiments. So I'm going to do some live API security testing um, on a mocked API, by the way. So I'm not going to try and hack actual systems, but I'm going to demonstrate a few of the kinds of experiments that you too can do to get more information about the security of your APIs. Because those experts that your team or your company hires, and often the teams and the organizations that I work with often say, yes, we have pen testers come in 2 or 3 times a year to see what's the status of the security of our system. And that's a long feedback loop. You have to wait 4 to 6 months before your next security audit after you fix something, which is takes a long time. It's a long feedback loop. So wouldn't it be great if we could do at least get the low hanging fruit, do the straightforward API security testing ourselves? And I strongly believe that you can do that. And what I want to show you in this talk is how you can do that too. So let's get started. So the first thing I typically look for. So I've got an endpoint here that retrieves data for a user with a specific ID. So I've got my authentication set up, a user token, and I let me retrieve this data for this user 123. And that retrieves data for user 123, whose name is apparently Anna. Um, and there could be all kinds of other data in this response. I've been lazy and just mocked these two fields because the first point that I want to make is not about the data. There will be many points made about the data, but not this one, not for this specific experiment. One of the things I have learned to start looking at is response headers. Why? Because they can contain potentially interesting data. Not just interesting to us as testers or as users, but also interesting to hackers. For example, these headers tell me that the server that served up this response was an Nginx server and even a specific version of that Nginx header server, and that it runs on PHP and even a specific flavor, specific version of PHP. I've seen so many APIs return this, and I don't want to hate on PHP. I'm happy to leave that to others. But PHP especially is very good at letting everybody know, oh, we power this API. This API and the system behind it was built in PHP. The problem is when they advertise that it's built in PHP and even more a specific version of PHP, we have you, me, everybody can just have a look at Google and see, oh, this PHP version 828. Let's see if there are any known security vulnerabilities related to this specific version of PHP. Turns out there are. This is literally the top the top Google search result from a search on PHP 828 security vulnerability, a comprehensive list of vulnerabilities in this specific version. And some of them could even are even exposable, are exploitable. That's the word I was looking for, over HTTP, which means that if we know we have an HTTP built or an API exposing data over HTTP built in PHP version 8.2.8, we can exploit that. And all that information and those headers, that's out there in the open. So my recommendation from now on is if you inspect an API response, if you look at an API response, or if you have a tool look at an API response in your test suite, um, please don't just look to the status code, whether that status code is correct. Don't just look at the data. Is that data correct? But also, um, what does this response tell me about the system behind the API? Is it exposing potentially sensitive implementation details? Because all of that information can and will be used by people who want to gain access to your system. And it's not the people who should have access to your system who are going to exploit it. It's those people, let's call them hackers, who want access to your system, but who shouldn't have it. Another quick example of this is from the workshop and not the talk. So, for example, this is not an endpoint creating a user with a specific username. If I leave that username empty, I see a stack trace. Stack traces, just like these response headers, are a treasure trove of information for people who want to know more about the implementation of your system and potential security vulnerabilities into your system. Because I could easily feed this to any type of LLM, Claude, ChatGPT, whatever it is that you use, and say, based on this stack trace, what can you tell me about the implementation of the system? And it will tell you the programming language, the libraries that were used, the versions of the libraries that were used. And you can then again use that information to see, well, oh, if I know this API uses this specific version of this specific library, what do we know about potential security vulnerabilities and can we exploit them? To sum this up, um, inspect every API testing response or API response. Look at every API response to see, well, is there anything that could be classified as sensitive information? And again, that's not just in the data that's being exposed through the API, but I'm mostly talking about information about the implementation of the API itself or the system behind the API. Because all of that information can potentially be abused by people with malicious intent. Um, Another fairly simple and straightforward experiment that I can do as a tester is, let's see how my API responds to potentially malicious input. So, for example, let's go here. This is yet another endpoint to create a student in presumably some kind of student administration system. Um, if I say John is a computer science student, it will register John as a computer science student. Awesome. But I could also say, well, ooh, let's see what happens if I try and inject potentially malicious data into a system through the API. In this case, it's a fairly benign JavaScript snippet. But if this ends up in a database, and if that data is at some point sent to a web browser and rendered in a web browser, executed in a web browser, it could do all kinds of funny things with the data that's stored in a web browser. So this will just display an annoying but not very malicious alert. But it could also be a script that scrapes all the credit card data that's stored in your browser and sends that to, well, insert evil country of your choice here. So I want to make sure that these kinds of potentially malicious inputs, and this could be malicious JavaScript. It could also be, let me go to XKCD here. It could also be malicious SQL code. So SQL injection. So if your API or the system behind your API does not properly sanitize SQL statements, it could do all kinds of interesting, and by interesting, I mean problematic things with your databases. It could drop tables, it could drop the entire database, it could do all kinds of wonderfully annoying stuff if you don't properly sanitize that input. One resource that I typically recommend to people is the big list of naughty strings. There's a URL, there's a link to this list in the slide deck. You can see it right here on the screen. You can all, of course, also Google it. Just Google big list of naughty strings. Um, Please don't do a Google image search on it. That's going to be maybe leading to some interesting results. But this is a resource that is very useful because it has a lot of interesting values that you could try and inject into a system. For example, via an API. So there's emojis, weird character sets. There's all kinds of JavaScript. And this is where I got the inspiration for my example. There's examples of SQL injection here. There's examples of server code injection. And I want my API to not just accept these values because they could do all kinds of wonderfully interesting, invalid, unacceptable things with my system or with the browsers that the users of my system use, for example, if I allow my API to inject these values into my system. Um, so please make sure that your APIs block this kind of data, that they validate the input, that they sanitize the input, and make sure that they don't allow you to inject these values into your system. Basically, don't be eBay in 2016, where they had a URL, an endpoint with a URL parameter that they didn't validate, that they didn't sanitize, which led to a cross-site scripting XSS vulnerability, because people could assign malicious value containing malicious JavaScript to that URL parameter, which led them to gain access to eBay seller accounts, sell products at a discount, steal payment details. That's probably not what you want as the developer, as the builder, as the publisher of a system. So please make sure all your endpoints, and I showed you an example of a JSON request body, but we want to test this basically for any way in which we can insert data into a system. That could be a query parameter, it could be a path parameter, it could be a request body, it could be request headers. All these values that we pass from a consumer to a provider, we want to make sure that they are properly validated and sanitized. So again, these are fairly straightforward experiments, tests to perform. No very deep security testing knowledge necessary. So you can basically, well, go and start and do that right away. See how the APIs that you are building in your team, that you are using in your team, respond to potentially malicious input. Um, Next up, I want to talk a bit about OWASP. OWASP is the Open Web Application Security Project, a group of researchers and practitioners that do a lot of research around security. And one of the things that they do, one of the wonderful things that they do is compile lists of popular security vulnerabilities. In 2019, they published their first version of the API security top 10. And so they made a list specific to API security vulnerabilities. 2023, they published an updated list, and that's also the most recent one. So I want to show you a couple of entries from that list and what they mean and how to test for them. First example, finding data that you shouldn't have access to. Let's have a look at an example of that. So I've got an endpoint here that retrieves data for a bank account. So I'm authenticated as Susie. Susie has a bank account with this bank, and her bank account number is 543, which means that if I retrieve this data, if I send this HTTP GET request, I should be seeing Susie's bank account details. So far, so good. No security problems here. This is just how the API is meant to be used. Um, Susie is a bit curious, or not necessarily, but Susie's curious. So, well, if 543 is a potentially is my account, then maybe because that 543 looks an awful lot like just an auto incremented integer. So maybe account I can also try and retrieve the details for account ID 542. Again, Susie only has a single bank account with this. So 543 is her only bank account, the only bank account to her name at this bank, which means that she probably shouldn't have access to this data. And turns out she doesn't. It returns 404, which is actually a good thing. So I get into this discussion sometimes. Should we return a 404 in this case, or a 401 unauthorized, or 403 maybe? I think, and that's not just me, but a common practice is to return 404 here. Why? Because this exposes the least amount of information to Susie. Susie shouldn't even be aware that 542 is an existing bank account with this bank. There's no reason for Susie to know that, which means 404 could either mean there's no such bank account, or it could mean there is a bank account 542, but Susie shouldn't have access to it. Doesn't really matter. 404 is probably a good choice, a sensible choice for a response here, for the status code. But of course, with tools like Postman or Bruno or restassured.net or whatever, any kind of API testing tool, we could probably fairly easy say, well, let's do this experiment for a wide range of potentially valid, potentially existing resource IDs, in this case, bank account numbers. So I've added a little script here that says, well, oh, let's see if for all the values that I test this for, the API returns a 404. Except for one, because 543 is valid bank account that returns to 200, so that makes sense. So let me quickly. I've prepared a little CSV file here with a range of bank account numbers from 500 to 599. I want to use that locally, and I want to only run this request. So what I expect, so it's 100 bank accounts, 500 through 599. 543 is in there. So I expect 99 passes, 99 times the API returns a 404, and one failure because that's 543, that's Susie's bank account. So I can run these tests, run 100 tests. And what I see is, ooh, there might be a problem here. So keep in mind, for all of these requests, I'm authenticating as Susie. As Susie should only have access to a single bank account, 543. Turns out she does have access to bank account 543, but she also has access to bank account 572. So authenticating as Susie, she now has access to data that's not hers to see. And this is an example of the most common, according to OWASP, according to the OWASP 2023 API Security Top 10. This is an occurrence of the most common API security vulnerability. OWASP calls this broken object level authorization. Um, OWASP is sometimes a little bit funny with the names that they give to these vulnerabilities. But basically, what it means is getting the ability to get access to data that, based on who you are, you shouldn't have access to, or a data leak, a data breach, actually. And again, that's the number one security vulnerability on the 2023 OWASP API Security Top 10. Broken Object Level Authorization, or BOLA. Some of the things to look out for here as testers, if you want to test for this specific kind of vulnerability, is those resource IDs. In this case, for this specific example, the bank account IDs. Are they predictable? In this case, they were very predictable because it's just an auto-incremented integer, or it looks like just an auto-incremented integer. Another example of this is when those resource IDs are findable. So maybe for example, there's an endpoint that just returns a list of all the valid resource IDs, of all the valid bank account numbers in this case. Whether or not that endpoint should even exist is a little bit outside of the question for this specific example. It's a good question, but if that exists, is it accessible by anyone? Can anybody just see, oh, these are valid bank account IDs? Because that makes it very easy for people to just um, create a list of valid bank account IDs and loop over them to see, well, can I actually access that data? So if they add those resource IDs are either predictable or findable, you make it easier for people to scrape for data and look for data that they maybe shouldn't have access to. Another problem that we saw here in passing implicitly is an insufficient rate limiting, or in this case, a complete lack of rate limiting. Rate limiting is a restriction on the number of requests someone can make from a single machine to a specific endpoint in a specific time frame. So if you don't impose a rate limit on your APIs, you make it a little bit easier, or sometimes a lot easier, for people who want to gain unlawful access to your data to just start scraping that data, start looking for data, start going over long, long lists of potentially valid resource IDs to see, well, is there a breach? Is there a hole? Is there a weakness, a flaw in the security of this API that exposes data that I shouldn't be allowed to see? In fact, a insufficient or a total lack of rate limiting in itself is also featured on the 2023 OWASP API security top 10 list. It's on number 4. And OWASP calls that unrestricted resource consumption, which again translates to insufficient or a total lack of rate limiting. So that's two very common vulnerabilities in one go. Does this happen in real life? Well, there's a reason um, this is number 1 on the OWASP list. Yes, this happens a lot. This is just one example. USPS, the US Postal Service, their site exposed data to anyone, to any of their users, for all 60 million other users of that website. And again, that's a lot of data. That's a lot of people. That's a lot of users. It's also US Postal Service. It's quite a big organization. So this happens. This happens all the time. And as you can see in this little screenshot in the article, it even says, well, in some cases, they were even able to modify account details for other users, which is another example of some things of another example of things that I want to show you. And so if we can see data that we're not supposed to see, maybe we can find out, can we also modify that data? So let's go back to Susie. Um, Let me see if this is configured correctly. Yes. So we already established that Susie can, oops, this one. Susie can see Andrew's bank account ID. And she says, ooh, that's a lot of money. Assuming this is US dollars or euros or I don't know. This in any case, this is a lot of money. Um, she said, well, ooh, let's see. I want that money. Um, so she could just find out who Andrew is and maybe try and marry him, but maybe there's another way to get access to that money. She says, well, ooh, let's see if I can withdraw that money. So let's assume that for this specific API, for this specific bank, this is the operation that is performed if you withdraw money. And or and if we send this, well, it works. That's not what we expected. Although it is what I expected because this is my example, but this is just an example of trying to, based on we are trying to modify data that you shouldn't be able to modify. So again, I'm authenticating a Susie, but apparently I am now able to withdraw money from someone else's bank account. And the next time Andrew is going to check his bank account details. Let me just clear this response just to show you what happens. Next time Andrew retrieves it, he says, oh, where's my money? My money's gone. Where's my money gone? This is an example of another kind of vulnerability. So BOLA, broken object level authorization, is the ability to see data that you're not supposed to see based on who you are. This is an example of broken function level authorization, which is less common, but it's still number 5 on the 2023 list of by OWASP. So broken function level authorization is the ability to modify or use data that you're not supposed to modify or not supposed to use based on who you are. That's broken function level authorization. Another example of this is of broken function level authorization is checking if regular users have access to admin or other kinds of endpoints with elevated permissions, for example. And because they're a regular user based on who they are, they shouldn't have access to those endpoints, but maybe they do. Um, both these vulnerabilities, so broken object level authorization and broken function level authorization, they share a relationship because they're both often caused by broken role-based access control implementations. And so a broken mapping between who are you and what permissions do you have in our system. Um, which means that if you stumble upon data that you shouldn't be allowed to see, which again is more common than you think, it's probably a good idea. And I think, yeah, it's our responsibility as testers to start digging a little deeper and see, well, if we're allowed to see that data, what else can we do with that data that we're not supposed to see in the first place? Not because we want to get rich quick or break the system even more, because I think that is our professional responsibility, just to show and tell a story about how broken the system really is and what the risk of. And because not everybody might be saying, well, oh yeah, if they see that data, first of all, they probably say, no user would ever do that. Well, they will. But maybe say, well, oh, if they're only able to see that data, that's maybe not that big of a problem. But if you can also show them, well, that they cannot just see that data, they can modify, use that data, and that makes for a much more compelling story of for fixing it, basically. Um, another example of this is from, I don't know exactly what year this was. I think it was in 2023. Um, on Coinbase, one of the largest cryptocurrency platforms out there in the world, someone was able to buy one flavor of Bitcoin, Ethereum, with or sell Bitcoin um, using using a cryptocurrency that they don't have access to. And so they were able to modify data which they shouldn't even have access to in the first place based on who they are. Um, so that is another example of a broken function level authorization vulnerability. How much time do I have left? Uh, Harsh or Deepti?
You have around 10 minutes.
10 minutes. Awesome. Is that including questions
Question
or?
and yes, it is including, but we have like a couple of questions, but we can accommodate that. Let's go.
Oh, okay, awesome. I don't know about your schedule, but I'm happy to do a couple of minutes extra. But that's good to know. Thank you very much. So
Yeah.
I'll do one more example for now, and then I'll wrap up. So ordering a game, for example. Um, another flavor. That's no, that's this one. So let's say this is an endpoint where we can order games with a game shop. So I like Super Mario Kart, and I can order Super Mario Kart in this uh, at this game shop. Awesome. I can order a single copy, and I can even, I don't know why I would want to, but I could even order 100 copies, and that game shop is probably happy to sell me 100 copies of Super Mario Kart because it means money to them. And let's say this game shop has a limited sale of very limited edition items. For example, not Super Mario Kart, but Gamma Attack. For those of you who don't know, and that's probably most of you, Gamma Attack is the world's rarest video game. There's literally only a single copy in existence, and the console that it should be played on doesn't exist anymore. Anyway, it's just an example. So we have Gamma Attack, and this game shop has imposed a one item per customer only, one copy per customer only restriction. So I can order a single copy, that's accepted. But if I try and order even two, it'll tell me error, you can only order a single copy of Gamma Attack. Um, some people might stop here and say, well, oh, that works, especially all the requirements are fulfilled. But what they don't, what they forgot to check and what people sometimes forget to check. What happens if I order a single copy multiple times? Turns out that is allowed here. So um, there are ways to order multiple copies of a one copy per customer only item, and that's just by placing multiple copies for multiple orders for a single copy each. This is an example of another kind of vulnerability that is called unrestricted access to sensitive business flows. So there's not necessarily something wrong with authentication, authorization, those kinds of things, but this is a vulnerability where your API allows you to misuse, abuse, or just circumvent, avoid limitations implemented in some kind of business process. Unrestricted access to sensitive business flows. And that's number 6 on the OWASP list. So, how do you prevent these kinds of vulnerabilities? Um, by talking to each other, and this is where testers come in because testers are very good. We are very good at coming up with all kinds of ways in which the system might not work. Also, get involved and identify, well, all these kinds of edge case scenarios, whatever. Identify the sensitive business flows, identify ways in which people could take advantage or abuse these business flows, and then take your prevention measures, such as human detection, for example, analyze it and see if we can find any non-human patterns. So, for example, if there's a ticket sales for a popular artist, for example, going on tickets or go on sale, maybe we want to implement something that detects if we are dealing with a human or dealing with a script or a bot here. So if there's literally only a couple of milliseconds between someone placing an item into a cart and moving to the checkout, you're probably not dealing with a human being with a bot. And this is just one very simple example of a non-human pattern. Um, One final thing to mention here is that none of these countermeasures, so authentication, role-based access control, rate limiting, detection of non-human patterns, none of these countermeasures by itself will guarantee that your API is going to be, or your system in general is going to be secure. Because all of these countermeasures have their own weaknesses. But if you implement enough of them, it will hopefully, likely, and that's something that we should test for, that we can test for, reduce the risk of people abusing your API to an acceptable level. And that is called the Swiss cheese model in security. So every security measure that you take, again, authentication, rate limiting, whatever, is a layer of Swiss cheese, basically. I'm going to skip this one. So we covered quite a few potential security issues today. We didn't actually cover, because I'm out of time, number 7, server-side request forgery. But we did cover the other ones. The ones that we skipped, for example, server-side request forgery is the ability to gain unlawful access to systems through misconstrued or malicious URLs in requests. Broken authentication is, well, literally add flaws in your authentication system. Broken object property level authorization is very similar to broken object level authorization, but instead of dealing with access to entire resources, it deals with access to specific fields or elements of resources. Security misconfiguration is just an umbrella item on the list for all different kinds of, well, misconfigurations in the security of your system. Improper inventory management deals with, for example, not uh, removing older versions of your API that have security issues, or not removing vulnerable endpoints in your API, for example, because people have a hard time tracking all the kinds of versions of APIs and all different kinds of endpoints that they've deployed um, into their production environment. And the last one, number 10. So numbers 1 through 9 are all problems on the provider side. Number 10 is a problem on the consumer side of an API. It's because APIs return data. And as a consumer of that API, I should also make sure that I don't accidentally consume potentially malicious data. Maybe that provider, especially if I don't trust them, maybe that API provider returns potentially malicious JavaScript or SQL statements, for example, or just other kinds of potentially malicious data. And before I consume that as a consumer, I should also make sure that the things that I consume are actually secure, and that's what number 10 on this list deals with. So where to from here? So this talk hopefully gave you some ideas of how to get started with API security testing. As you've hopefully seen, a lot of these very popular, you can get started testing for common vulnerabilities, common security problems in APIs, again, with just common API testing tools and a healthy dose of curiosity, creativity, and some common sense. You don't necessarily need to be an API security testing expert to do these kinds of things. I'm an example. I'm not an API security expert, not by any means, and I can do these kinds of experiments. So I'm pretty sure that you can do this too. If you want more, some more info on API security, if you want to get more content, watch videos, maybe follow some online courses, I can highly, highly recommend API Sec University. That's an online platform providing a lot of free video courses on API security and API security testing. And all of these, again, these courses are free and they are really, really well done. They're of very high quality. So if this is a topic that you think is interesting, I definitely recommend checking this out. So we can go. I've got a couple of minutes for questions. I don't know what the exact schedule for the rest of the day for the conference looks like. I really enjoyed talking to you. Thank you very much for that. If there's any kind of questions or comments or feedback, or just want to get in touch, I have an email address, I have a website, I have a LinkedIn profile. So by all means, get in touch. But I'd love to hear from you now if there are any questions.
But thank you so much for thinking through and putting so many scenarios for us. I think while you were showing the APIs, Charles had a question if the rate limiting be bypassed with a time wait between calls?
Yes. Again, just like all of these other slide that Swiss cheese model kind of thing, rate limiting in and of itself is not a guarantee that everything is going to be secure. So yes, um, through experimentation and just trying things out, you can find out, oh, this is probably the rate limit, and then you can do lots of requests and just stay just below that rate limit. For example, time offs, pauses between different requests. Yeah. And so rate limiting is not a foolproof security measure. It's just one um, technique, one pattern that you can use when developing and publishing an API to make it harder for people to abuse it. But it's not a guarantee. It's not a foolproof way to make your API 100% secure. Not at all.
Thank you. Thank you, Bas, for answering that with us. We really appreciate you sculpting the sessions in detail and showing so many examples and scenarios. We really had a good time hearing to you. Thank you for your session.
Thank you so much for having me, Deepti, and for being a wonderful host today. I really enjoyed it.
Thank you, Bas.